In this video, we will discuss the converse of Pythagoras theorem. First of all, we will see what exactly is the statement for the converse of Pythagoras theorem. We already have studied Pythagoras theorem, in which we have seen that in a right triangle, square of the hypotenuse is equal to sum of the squares of the remaining two sides. So what will be converse of that statement? The converse of that statement, if we have a triangle in which square of one side is equal to the sum of the squares of other two sides, then the angle opposite to the first side is right angle, or we can say that the given triangle must be a right triangle. So let us see the statement of this theorem. In a triangle, if square of one side is equal to the sum of the squares of other two sides, then the angle opposite to the first side is a right angle. It means that if we have a triangle in which square of one side is equal to the sum of the squares of the other two sides, then that triangle must be a right triangle. Let us see how to prove this. Now, first of all, we will draw figure to prove this theorem. Let us draw a triangle. Let us say ABC is the triangle. Now, in this triangle ABC, we have given that square of one side is equal to sum of the squares of the other two sides. So, let us assume that AC square is equal to AB square plus BC square. Now, what we have to prove? We have to prove that the angle opposite to the first side, that is AC, is right angle. So, we will prove that angle B is equal to 90 degrees. Okay, so this is what we are going to prove. Now, in order to prove this theorem, we require to do a construction. So, what will be our construction? We are going to construct another triangle, say PQR, which is right at Q, such that its side PQ will be equal to side AB of the given triangle ABC, and side QR will be equal to side BC of the given triangle ABC. So let us construct a triangle in the required way. First of all, we'll construct a triangle PQR. This triangle is right angled at Q. Its side PQ is equal to AB and side QR is equal to side BC. So this is the construction required to prove the converse of Pythagoras theorem. Now what are we going to do? We are going to prove that these two triangles are congruent. And if we can prove that they are congruent, we can say that all the corresponding sides as well as angles are equal. So accordingly, we can say that angle B will be equal to angle Q, and then we can angle B is equal to 90 degrees. Let us see the proof of the converse of Pythagoras theorem. Let us once again consider the figure which we have drawn. The original triangle ABC, and after construction we have drawn a right triangle PQR which is right angled at Q. Its side PQ is equal to AB and QR is equal to BC, right? So here, first of all, we will consider triangle PQR, which is the new triangle which we have constructed. In this triangle, angle Q is equal to 90 degrees. It means that it is a right triangle. And as it is a right triangle, we can use the Pythagoras theorem in this triangle. So, as PQR is a right triangle, we can write square of PR is equal to PQ square plus QR square by Pythagoras theorem. But we have given that side PQ is equal to AB and side QR is equal to BC. So, let us replace those values. So, we will get PR square is equal to AB square plus BC square. We have replaced PQ with AB and QR with BC. So this we have written from construction, because we have done the construction such that side PQ is equal to side AB and QR is equal to BC. Let us consider this as equation number 1. Now we have given that AC square is equal to AB square plus BC square in the given triangle ABC. Okay, so this is given to us. Now from equations 1 and 2 we can see that right sides of both the equations are equal. It means that left-handed sides must be also equal. So from equations 1 and 2 we can write PR square is equal to AC square. Okay, because the things which are equal to the same thing are equal to one another. So taking positive square roots on both the sides, we will get PR is equal to AC, taking square roots on both the sides. Let us consider this as equation number 3. Now we will prove that triangle ABC and triangle PQR are congruent. So let us consider triangle ABC and triangle PQR. In triangle ABC and PQR, we have constructed AB is equal to PQ and BC is equal to QR. This we can write because of our construction. Okay. Then after that, we have proved that PR is equal to AC. So side AC of triangle ABC is equal to side PR of triangle PQR. This we can write from equation number 3, which we have just proved. So here we can see that all the three sides of triangle ABC are congruent to corresponding sides of triangle PQR. So we can say that triangle ABC is congruent to triangle PQR by side congruence test. Now as both these triangles are congruent, all the corresponding angles must be equal. So it means that angle B must be equal to angle Q, because they are corresponding angles of congruent triangles, or we can say they are corresponding parts of congruent triangles. But we know that angle Q is equal to 90 degree, so we can write angle B is equal to 90 degree, because we have replaced the value of angle Q from the given, right? So in this way we have proved that angle B is equal to 90 degree in triangle